We're continuing with the Further Mechanics 1 course. Today, Chapter 1.2, the key points of conservation of momentum. In the previous chapter, we saw that we can answer questions by using the impulse-momentum principle. That is, when two particles collide, we know from Newton's third law that the impulse from the green to the red and the impulse from the red to the green will be the same, but in opposite directions. In this chapter, we use an equivalent formula which is often a bit easier and quicker to use. It also means we don't have to worry too much about the direction of the impulse. Let's take a look. This is a proof by using the impulse-momentum principle to get the formula for conservation of momentum. You don't need to know this proof, you just need to know the formula at the end. We've got two particles, masses m1 and m2, initial speeds u1 and u2, and final speeds v1 and v2. I'm making all the directions right here, which means I'd have to use negatives if anything was going to the left. The impulse, according to the green particle, is going to be m lots of v minus u. So in this case, it's m1 v1 minus u1. But it's going to be minus I because the impulse from the red particle acting on the green particle is going left. For the red particles, it's really similar, m2 v2 minus u2. And this time the impulse is going towards the right because the green particle is acting on it in the positive direction. We label these 1 and 2. We can set the equation minus 1 equal to 2 and rearrange from there. So m1 v1 minus u1, but negative m2 v2 minus u2. If I expand the brackets like this, and this, and then move the negatives to the other side, and then rearrange slightly, we get m1 u1 plus m2 u2 is m1 v1 plus m2 v2. That's a lot of m's, u's and v's. However, it's much simpler if you remember it as the momentum of green before, which is m1 u1, plus the momentum of red before, which is m2 u2, is equal to the momentum of green afterwards plus the momentum of red afterwards. So either formulation in words or as a formula is the conservation of momentum. And this means that we don't have to use the impulse to answer certain questions, we just need the masses and the velocities. In some questions, two particles will collide and then coalesce, meaning that they can be considered as one, almost like they are glued together and travelling as one. You can either treat it as two particles travelling at the same speed, or as one particle with a combined mass of red plus green, so the masses of the two. If you consider it as two separate ones, you consider the masses separately, with v being the same, a common velocity. If it's one particle that you consider, you only need one velocity. Choose whichever is easiest for you. That's it for this section and Chapter 1 for the AS content. We will see these themes again in Chapter 4. Now make sure you're fully understood with the examples video and the past paper questions video.